Now let's talk about what some of the drawings of three-dimensional objects in your book are showing you. This is on page 43 of your textbook, and I'm going to look at this picture here. And as this picture is drawn, we are looking at these two faces here and the top. And I know that because this segment here is dotted, so that you can see that if this prism were filled with something such as dirt or sand or something else that's solid, then you would not be able to see this segment back here. Now let's look at page 93 of your textbook. I'm going to look at this picture here. And as this picture is drawn here, we're looking at the top and the right face over here. And we're looking at the front here. And you can see that if this prism were filled with something such as dirt or sand, then you would not be able to see this edge back here or either of these edges here. And that corresponds to these edges that you see here. Now let's look at part D and E of example 1 here. Line CG corresponds to this edge here, and line BF corresponds to this edge here. And of course, these lines are actually drawn as segments in this picture, but you can imagine that they are lines if you extend them on out forever in both directions. Now, as your book tells you, line CG and line BF are parallel, and that's because they never cross each other if you extend them out forever, and there is a plane that contains both of them entirely, as you can see by this piece of paper here. And of course, this piece of paper is not a good plane, because if it were a good plane, it would extend out forever in these directions here. But it works for our purposes here. Now, part E, line FH and line CD. Line FH corresponds to this edge here, and line CD corresponds to this edge here. And you can see that I cannot take this piece of paper and make a plane that entirely contains both of those lines. So we will say that they are skew lines. Now let's look at page 635 of your textbook. This is an example of what you see in example 1, part C. It is called a cylinder. And you can see that as this picture is drawn here, we're looking at the bottom of it, and then this top edge you would not be able to see. This is an example of what we're looking at in part G. This is called a pyramid because all of these faces here meet in a single point. And this is an example of what we're looking at in part H. This is called a hexagonal prism. It is a prism because it has two bases that are parallel to each other. And it is a hexagonal prism because those bases are in the shapes of hexagons. Now, in chapter 13, we talk about something called the height and the slant height of pyramids and cones. And the height of this pyramid here is going to be the length of this segment. And you see that I have gone from the point up here and I've formed a 90-degree angle with the base. So the height of this pyramid would be the length of this segment here. The slant height is the length of the segment that starts up here at the vertex and forms a 90-degree angle with this edge of the base. So the slant height of this pyramid would be the length of that segment there. Similarly, the height of the cone would be the length of this segment here, and the slant height would be the length of this segment here.